Hello, friends. I, Professor Kisan Bidkar, today going to deliver a lecture on canals. So, in this particular unit, we are going to study the various types of canals, components, as well as some hydraulics of sediment transports. As well, can observe there are some losses that are occurring in the canals. That's why canal lighting is also important. So we can see one by one. You can observe this is a big canal. Canal is nothing but what? It is just a channel, but it is lights for supplying water for irrigation purpose or any other purpose that can be solved for the farmer's part. So we can define canal. It is nothing but a artificial channel which can be constructed on a ground to just deliver the water from river to the reservoir fields or field channels. So we can classify the canals according to the alignments. And that is first one is a ridge canal that is constructed on a ridge, and second one is the side slope canal. The another classification that is called as the classification based on position. It may be a main canal, branch canal, major distributary, minor distributary, or it may be water course, field channel, as well as the headwork is there. The contour canal is also there. So in case of contour canal, say you can see that these canals run along a contour line. So it means that canal is going to take off from the reservoir and it going to follow the contours of the topography provided there. And that's why these contour canals, when we are going to irrigate one side of the ground as well as the other side, you can observe here. This is sloping here on this word, sloping on this word. So this is going to deliver on the both side. So this contour canals longitudinal slope is given to enable water flow by gravity. So this is a long length slope is provided to this canal. That is the longitudinal slope. Now what is the advantage of this one? So this can be used or it is suitable in case of hilly areas. And to contour the canal longitudinal slope, that is given to enable the water to flow by gravity. It may have some disadvantage also. There may be a large number of sedivores. It can irrigate only on one side. Then the ridge canal or ridge alignment. This ridge canal have the another name as a watershed canal. These types of canal laid along a ridge or according to nature of that slope or watershed. So it can irrigate on both sides and thus irrigates area on the both of the sides. These canals are economical as there is no so much city works required because city work will carry the construction cost more is there. We can observe here this is a ridge canal. You can see here this is the ridge canal is there. So this drain is there. This is a ridge line just according to this one. Here it is a drain. It is a drain. The advantage of this drain is it can irrigate on both sides. You can observe here this particular canal irrigating on this side as well as it is irrigating on this side. So it is economical as it is going to irrigate on both the sides. More area will come under its command. It do not require so much city works. What are the disadvantage? The velocity of water needs to be controlled. Velocity should be controlled there. Less velocity. If the more velocity will be there, there will be the scoring of this bed. Maintenance will be required there. More maintenance will be required there. Then you can observe in the next figure, this is a side slope canal. This you can observe, this canal is there. So these are the contours 110, 106, and so on 98. The contour interval is here, 2 meter is provided here. So in this side slope canals, the alignment is there, canal not align along either ridge or contour, but it is aligned across contour. You can see these are the perpendicular to the contour, across the contour. These canals near parallel to the natural drain, as similar to the contour canal. It can also irrigate on one side also. These are canals are not intercepted by CDVers. That's why economical. Then the difference, one of the different points that are going to can see observe in case of contour canal as well as a ridge canal. First is contour canal follows the following contour, while ridge canal is on highest or predominant ridge there. In case of contour canals, the main canal is usually provided in its head ridge, just nearer to the reservoir, as working as a contour canal. But in case of ridge canal, this main canal is provided lower ridge. Here it is a head ridge, here it is a lower ridge, and all other canal can be as a ridge canal. It may have this contour canal have large number of sedivers because canal is running across a contour, and here less sedivers are there. It do not have any fall there, but here there may be the canal falls because gradient is more. That's why we have to put some falls there. So it can irrigate on one side, and this ridge canal can be irrigated on both sides according to its topography. It's a 50% efficiency. It is best and most efficient as compared to the contour canal. So it leads to more seepage. Here less seepage, more length, so more loss of land. It leads to less loss of cultivable area as land at reach is poor quality is there. So here you can observe this canal network is there. This is the main river, this is a dam, it's a reservoir. Water stored behind the dam is the reservoir. From this main river, you can observe these are the various outlets that are providing here. So this HR, a regulator there. This is downstream side, this is upstream side. Then this contour canal that is running along the contours there. You can observe these are outlets are going on there. So this a canal network is there. In canal network, the ultimate or final member will be the water course, or it is a field channel is there. You can observe here, for controlling the water through this canal, we are putting some head regulator and cross regulator. So when the canals are branched or taking up from reservoir or main canal, in the distribution system, this head regulator is provided to divert this discharge from the reservoir to canal or say a main canal to a branch canal to control the regulate of flow or discharge, and it also avoids or controls the silt entry in the taking of canals. So this is a head regulator called as HR. Then you can see the CR, cross regulator. When it is required to raise the water level in the main canal in order to regulate the flow in branch canal or to stop the flow in case of repair or maintenance of the downstream side, we are going to provide the cross regulator. We have to utilize this cross regulator. It diverts the silt overflow water into the nearby river or stream during flood control. These are the important structures that are provided there. Then this is a escape, canal escape. This is called as a canal escape. At the end of the main canal or allow escape of the silt water into the waste channel and then to the natural drain during the rainy season. These escapes are provided. These are mostly used in case of rainy seasons. Then these are the outlet that is provided. You can observe this is the outlet is provided here. So to admit the water into the distributory miners, these water course or field channels, these outlets are provided here. So outlet allow the water to flow here. No parts of the canal system. So it may be divided into main canal, branch canal, major distributary, minor distributary, and the final will be the field channel or say water course. You can observe here some diversion work is there, river is there. So this is HR. HR regulates the flow of the upstream side or in the river to this canal, and this main canal do have this branch canal. So the main canal, branch canal, this classification may be according to discharge capacity flowing through it. You can see this is a minor. These are the minors are there. Okay, minors and majors. This is a branch canal. This is a branch canal. This is a branch canal. These are the minors are there. So this is the parts of the canal system. So this is the main canal. This canal is taking from river. That is the from main canal. The function is to carry out the total water and to distribute it to the canal system. Then you can observe this is a branch canal. So it takes from the main canal. Its discharge is less, 5 to 25 meter cube per second or cubic there. Then you can observe the major distributary is there. Okay, this discharge is from say 0.25 to 5 cubic there. Then the minor distributary is there. This is discharge capacity is 0.25 cubics, and water course or field channel is the ultimate device in the canal system where these small channels takes water from the outlet or distributor and supply it to the agriculture field. This is the last unit provided there. Then the water course or field channel, that is I'm just telling you field channels. So this water course or field channels, these are the ultimate members provided in a field or in a farm. So you can observe from this outlet, these field channels are carrying, and these field channels are supplying water to this particular say the area. So on both side it can supply, on both side it can supply. So outlet, from outlet water goes to the field channels, and field channels supply the water to the fields there. Then headwork. So headwork is nothing but what? It is the work constructed to store, divert, and control the river water and to supply it to the main canal. That is the headwork is there. Now how to fix the alignment of the canal? So some points have to be considered in alignment of the canal. First point is along the alignment of canal, the CD works should be minimum so that the cost will be reduced. It should be such that water flows to the gravity in a channel or canal. This canal alignment should be such that there should be less earthwork cutting or earthwork filling so that the optimization will be there in construction cost. The alignment canal should be such that it can cover maximum command area. Command area is nothing but the area where this canal can provide the water efficiently as well as economically. That is the command area. Its length should be minimum. Curve should be minimum. And it should not be made in rocky or crack strata. Then this is a cross section. You can observe here. This is a cross section. Somewhere there will be the cutting, somewhere will be there the power pit. That is the filling is there. Okay. In order to achieve the economy, we may have the conclusion that the volume of cutting should be volume of filling, or depth of cutting should be equal to depth of filling. These are some extension that are provided as a, these are called as a berm. You can observe here, these are the bumps are there. See, this is DC. This is the depth of cutting here. This is GL, and this is the width of the, say, the canal. This is the bottom width, and this is the top width of the canal is there. This is general cross section of the canal in embankment. That is, most of the canal is in filling. Then this is a cross section of the canal. This is a bed slope, bed of the canal. This is the top width. This is the bed width. These are the bed slope. Side slopes are provided here. Bed slope will be along the length of the canal will be there. You can observe these are some of the figures are there. What are the losses that may occur in case of the canals? So, in order to avoid the canal losses, we are going to provide some lining of the canal. Lining of canal is nothing but what? To apply the materials, impervious material on the perimeter of the canal. That is called as a canal lining, so that there is a less seepage going to occur. So, some relevant considerations to be considered. That is the why we have to do the lining. Then selecting what are the type of lining and to implement that lining. This is an important part that will be covered in the next lecture. Thank you.